Ready, yeah. All right. Hey guys, I'm Rajat, and I work out of Red Hat, and we do lots of open source stuff. And before we begin, so this is where you guys can find me. This is my GitHub and LinkedIn, so hit me up. All right. So today we are going to talk about auto-healing clusters and negative testing. So before we begin, I wanted to know, like a show of hands, if anyone does any kind of negative testing ever done. Like, have you guys ever done any kind of negative testing? Oh, great. All right. All right. So before we talk about negative testing, we'll talk about auto-healing clusters. So what is an auto-healing cluster? So basically, it's a kind of cluster which basically monitors itself, and whenever there is a degradation of a cluster, it will start a recovery process. So it will always make sure that there is no kind of degradation happens in a cluster. All right. So now let's jump into testing. So this is what society thinks about people doing testing. So all right. So in particular, we'll talk about negative testing and how it works. So these are some very basic examples for negative testing. So basically, what negative testing is, your system or your application or your cluster should be ready to handle gracefully all the unexpected situations. So we'll jump back. As you can see here is that these are unexpected situations. These are not the desired input that our application wants. So if a user or somebody enters these kind of input, our system should be able to handle these type of situations gracefully. So we'll look into more complex example and more practical later in the slides. All right. So why do we need negative testing in OpenShift or Kubernetes, as we say, is to obviously to detect unexpected conditions, and if we'll cover all the unexpected conditions, we'll also prevent the cluster from crashing. So, okay. So before we jump into practical scenarios, I just wanted you guys to see this. So this is the cluster, and this is the master node, the Kubernetes master node, and these are the worker nodes. So basically worker nodes are the one where you deploy your workload. So as you can see, these are OSDs. So OSD stands for object storage devices, and in short, you can say that these are the devices or the disks which are used to store data. So you can call them, like normal disk storing data. Then you have the mon. So basically mon or monitor, as we call. So this is used to watch over these OSDs. So if there is any problem with the OSDs, say your OSD is not working fine, or you are stuck somewhere while working with OSDs, you can always look into the mon, you can check the logs for the monitors, and you will have all your answers. And these are the RGW. All right. I also don't know, because I don't work with RGW, so I'm sorry what this means. So anyways, and these are the rook agent or the rook step discover. These are the operators. So in the entire, in this entire worker node, if there is any kind of problem, like if you want to have an overview of what's happening actually, you can always look into these pods. You can check the logs for these pods, and you will have your answers. So now let's jump back. So these are the practical scenarios I was talking about where you can perform your negative testing. So first is, what if the cluster gets disconnected from the network accidentally when an I/O was happening? Okay, so an input and output is happening, and okay, so suppose you are on this node, you are having one input and output, and let's just say your network, you got disconnected with the public network. All right, so what will happen? So you can always test this scenario by yourself, and you can have the output, and you can check if you already wrote any kind of solution for it. What I mean to say is that I'm sorry, I forgot. All right, the next scenario is what happens if my cluster, what happens to a cluster if a node shut down. So say if my entire nodes got shut down, so what will happen? What will happen to the data? What will happen to the monitors? What will happen to anything? So these are the scenarios that you can perform and check. If you have the corner cases written for these kind of situations, then it's good. But if it's not, you need to write it. So what are we testing today? We are going to test the disconnection of the cluster from the public network. Again, we are going to disconnect one cluster from the public network, and second is detaching the disks from a running mon. So as I told you, these are the monitors, and there is a disk attached to it where this monitor runs. So we are going to detach that and see the outcome. So, I'm sorry. Yeah, can you see it? All right. So here as it starts. All right, so this is the command to detach a disk from a monitor. So this is the name of the VM, the virtual machine where my monitor is running, or my node where my monitor is running. This is the name of that image, and then I'll just disconnect it. All right, so disk is, so now the disk is detached. Now we'll check the output of what is happening. So, yeah, so this is you can say it's kind of a dashboard where you can see the entire health of your cluster. So right now I'm running a Ceph cluster, so I can check the entire cluster. So right now there is no problem with my clusters at all, because health is okay. All my daemons are up, my OSDs, as I told you, my storage devices all are working since very fine. So, all right, so as you can see, as I just detached my monitor, disk from my monitor got into error status. All right, I was just highlighting it, so. And now as you can see, the status of my Ceph cluster has been changed. It says that 1 by 3 monitor is down. So that means when I negative tested it, there was already a solution written for it. So that means you have already verified it, that my cluster will work fine if it will get into a situation like this. So you need not to worry about it now. Just a second, and yeah, and there it goes. I'm sorry. Yeah, so as you can see, it's changed its status from error to crash loop back off. So that means it's kind of a loop. So what I mean to say is that it started a auto healing process. So it is constantly running in a loop, and it is trying to find the disk if it is there or not. It's just re-verifying it, but it's not finding. It's like my monitor is not able to find the attached disk. So that is why it's just running into a loop to find it again and again. So now what I'll do, I'll attach the disk again. So here the command is, all right. Yeah, so I think the player is there, so that is why you aren't able to see it. But yeah, so if you can see the command right now, this is the command to attach the disk back again to the monitor. Now we'll check what's the status again. So right now the health is still in the warning phase. Now we got a new error for container creating config error. So even if the disk is attached, still we are not able to get the monitors running again. So this is the problem. So now you have an output. Now you can report this back to developers, or you can write a code for this by yourself. Is that whenever you attach a disk, the cluster should be up and running again and again, but that doesn't work. So now I have to manually delete the pod, and so people who are familiar with Kubernetes, it's a concept, you guys must be knowing, is that it's a concept for replication controller, is that whenever you delete a pod, the pod will again come back up. So that is going to happen. That is what is going to happen. I've deleted the pod, and the pod will come back again. I'm checking the pod status again. So, yep. So as you can see, All right. Okay, again the player is there, so you cannot see it. But this is the mon, which was in the pending or in the error state. But since the player is here, so you are not able to see the. Oh, okay, good. I mean, so as you can see, it got into the running phase again when we deleted the pod. So this was one thing. This is the one testing that I did, is detaching the mon. Now we'll look into. Now, I'm sorry. Yeah, so now we'll look into disconnection of a cluster from the public network. So what we're going to do is that we are going to disconnect one entire node from the cluster by shutting down its public interface, public network interface. So let's see what happens. All right, so this is the node and this is the IP. And now we're going to get the, we first SSH into the node. And now we are going to get the public network interface for this node. Okay. All right, so this is the command that I'm typing for, is to shut down the public network interface. So once the public network interface is down, nobody should be able to SSH into the node. So this is what I was expecting before testing it. So now let's see the result. If it's behaving like the way it was coded, it's fine. But if it's not, then that's a problem. Yeah, so I shut it down. Now let's see the outcome, if I'm able to SSH into the nodes or not. Okay, still there is no response. So that is a good thing, is that once you have shut down once you have shut down one node, it's not able to give back any kind of information. So that's why it's into the, there is no further command, or this command is not getting completed. So now here I'm going to try to SSH into the same node again with the same IP. And as you can see, I got a warning that something nasty. It's possible that someone's doing something nasty, and I'm not able to SSH into the node. So that verifies the thing, is that once my public interface, network interface is down, nobody is able to access it. So, yep. All right, just to verify again, this is the pod that was running on the node that I just shut down. And let us just try to SSH into this pod. And let's see if this happens or not. Yeah, and again, I was not able to SSH into the pod, because the node that was, the pod on which this, the node on which this pod was running, that is already shut down. So this is happening as expected. So yeah, so that is how I negative tested these. That is how I negative tested these two scenarios. And yeah, that concludes it. And if you have any questions, so.
Okay, that was
Yeah.
how can we, do you have any ideas or suggestions how can we apply this technique for negative testing, self-healing, to something like more regular, like testing the web app or like a mobile app, or something not a cluster?
Yeah, so firstly, you need to have some kind of unexpected situations figured out already, which don't happen very often. And then you can automate things if you want, or you can negative test it. So. Yeah.
So when you inject your failure, the MON component detects them, and something triggers a reaction to that.
I'm sorry?
And something in the cluster triggers a reaction to the failure.
Sorry, can you come again with the question?
So, let me see if I understand the
Yeah, sure, yeah.
when you inject a failure in the
Yes, explicitly, yeah.
software, the MON component, the monitor component detects that failure,
Yeah.
and you can script some kind of reaction to
Yep.
that failure.
Yep. So,
At the node level.
yeah, node level.
But when the failure is too persistent, you
Okay.
delegate to the cluster,
Yes.
the replication controller,
Yes.
and you just launch a new one.
Yes, yes. Yeah. So,
Can you please summarize for those watching online?
sorry?
Can you summarize what you just discussed?
All right. So the thing that he was asking, if I understood correctly, is that if my mon was shut down and if there is some kind of permanent cluster damage happens, then what ones do, right? Yeah. So.
Any last questions? Please be quiet.
Me.
Okay, no more questions. Thank you very much.
So maybe like people are not familiar. Yeah, sure.
Yes.
Was it live streaming?
Yes.
So if anybody wants to check it out, how
You will receive an email where you can select begin and end of the talk. And then it will be recorded and published automatically. You will receive another email.
So right now there is no point of doing it live stream. Like if somebody wants to check it out right now.
Well, right now, exactly right now, no.
Okay.
Like it will be available in 1-2 hours. So you will get an email. Okay. So we have some presents for speakers.
Oh really?
We have a beer for you from Susan, from our we got these socks for speakers. So this is from us. Thank you. Thank you. Okay. Do you need anything? We need to put this microphone. Yes. HDMI. Yes.
Just put it like here.
Well, yeah. Here is good. Yes.
Yeah.
It's perfect. Just put this somewhere in your belt or your pocket.
Actually, I'll bring over a chair for some of it.
You have to stay between these sticker lines. This one for the camera to see you.
Ah,
Yes, and if you sit there, camera will not see you. So
that's-
people pretty much will be able to see you.
okay. Maybe can I put my laptop over here somehow? No, not really, I guess.
Really? You can put it here if this is comfortable for you.
10 minutes, I guess. We'll start right on time, right?
Yes, yes.
Yeah.
Time. You have 10 minutes.
Like getting a bathroom break and refresh.
Yes. You can try. It's just.
If you, like, I don't know, this space is good for you. You know?
But what will happen if I accidentally hit any of these buttons?
No, nothing. These are lights. You cannot hit them so hard that they do something bad. This is enough.
I think maybe I'll just be standing. Or. I mean, you think?
You can sit, but you hide behind the computer.
Yeah, it's a bit. I'll just try to do it standing. It's just going to be some typing.
Okay. You have 10 minutes. So you can sit down and relax. We're staying at the map, showing you how much time we have left.
Yeah.
When you have a question or discussion, repeat or summarize for the people who are watching on the live stream.
Yeah.
And for the recording, speak louder. if you can.
Yeah. I think I tend to speak pretty loud at these things, so I'm just afraid that I kind of blast these guys too much.
I will control this on the camera.
Ah, okay. Great. It's the first time I tried to do this basically in a very long time, so it's like, I think FOSDEM is just like a really cool conference, but it's also very casual, like, I sign up for this thing and I just walk in here on the day and then I didn't know if there was somewhere I had to go and sign up or something like that.
Didn't you receive like an email with instructions for the FAQ on the website?
Yeah, I tried to find some information, but I don't know.
No, we should do a Git repo.
Yeah.
Speaker survival guide.
Yes. Yeah, because I looked in the on the FOSDEM webpage for if there was some notes for speakers or something like that, but it's not like
Not really. It's like
no.
5 sentences.
True, but
You consent to being recorded. Everything is Creative Commons. That's it.
yeah, that's fine. Stresset for mig at skrive de her ting. Jeg skal ikke prøve det før.
Nej, det er det ikke. Det er godt at øve sig.
Ja. Ja, for det er sådan rimelig casual lige ved det. Sådan, så bliver det så recordet til alle folk. Så lige den gang. Hold det bare for det.
Ja, men så er det også. Så kan det jo kun gå op.
Ja.
Så man kan toppe det,
hvis du genererer en masse sådan, attention og sådan noget på... så kommer rigtig mange ind og ser vores ting, fordi bare folk faktisk forstår, hvad det er. Så er bare en mand i bare overkrop, så der...
Jeg kan også se videoerne, der er skyld på bordet, det
Ja. Ja, præcis. Så jeg tænker, det er jo en happening ud af det.
Det smager godt. Sådan op, jo.
Ja.
Får du det?
Fedt demo.
Hvad siger du?
Jeg fandt den, fikset den sidste fejl i morgen. En quest, sådan hver 10. gang, jeg startede ude op. Det er ikke godt.
Ja, det skal bare passe. Den her demo, fordi de unge.
Ja. Så, nu har jeg prøvet at starte det 20 gange, så er det ikke sker noget. Men det er også noget, man har lige kørt af bleeding edge-spil, man har.
Ja, så er der altså...
Bare for at understøtte, at man kan skrive mikro med UTF-8 i det, eller sådan noget. Så må man nok lidt fejl.
Ja.
$30. I thought it was 25 fast. Yeah, but I thought we started 14:25. We just moved it up, or what?
Sure. Ah, you can limit 14.25. Let me see. Oh, okay.